This is slide number 10 and I am your presenter Asloob Mudassar. Here in the picture I have shown three objects. The leftmost object is a wedge of crystal clear glass, acts as a phase object with a continuously varying phase. That is, the phase changes with the thickness. So the phase is minimum, the phase variation is minimum at the front face, and when we go towards the back surface where the thickness is maximum, the phase is maximum there. So this wedge actually provides us an object in the transmission mode, which is the phase object, giving us a continuous range of phase values. And in the middle we have shown a sinusoidal phase grating. You can see that the thickness of this varies as a sinusoidal function. Actually in principle 1 plus a sinusoidal function, because we have not shown the thickness on the negative side. So this is the thickness on the plus side. So this is actually 1 plus sinusoidal phase grating. And on the rightmost object we have embedded some object in the wedge of the crystal clear glass. You can see some objects over there, and this forms an amplitude and phase grating. So that when the light will pass through such an object, the phase of course will change from point to point due to the thickness of this glass plate, due to the thickness of this wedge, and at the same time there are some objects embedded in that one having varying amplitude, and so this will also act as amplitude object. So this is object. So this object is actually a phase and amplitude and phase object. And then we have some objects in the reflection or the scattering mode. So you see that these objects which we have shown previously, there we can write down their mathematics in analytical form very easily. But for those objects which are scattering the light, or from where the light is reflected off, the reflected off light and the scattered light, they are in such a form that we cannot write the mathematics for such objects. I mean that the analytical mathematics cannot be written for such objects, and so when we cannot write the analytical mathematical form of such objects, we cannot practically use them, we cannot analyze them mathematically or analytically. So you see that let's read the statement. A glass surface with a roughness smaller than the wavelength of incident beam will contribute more towards the reflection and less towards the scattering, whereas most natural objects being optically rough will contribute more towards the scattering and less towards the reflection. So these types of objects for which we cannot write the mathematics very precisely, that is the objects which are reflecting the light or the objects which are scattering the light, it is not easier to write their mathematics. So we shall not be incorporating those objects in our analysis in the course of Fourier optics. So this is the end of slide number 10.